Hey, good morning. How you doing? It's April 6th, a Monday, although the days all seem to run together now, but it is Monday, and it is Wetlands Week. So we'll talk a little wetlands this week and add that on to our list of ecosystems that you know something about. Just some upcoming events to remind you of. On Wednesday of this week, you can look forward to seeing Kevin's presentation on a wetland LTER. And just like we've done for Charlie and Henry, please watch his video, Kevin's video, and post questions and comments on Notebowl Bulletin. This is my way of checking in with you to make sure you're sort of following along. And then Kevin will do his best to respond to your questions. 1 week from today, you're going to have your third quiz. So this week, I will give you a review sheet on that and a little bit of instructions on it. It's going to be a little different than your other quizzes, of course, but it will probably be 3 essay questions that'll be open book, open note. And the best way you can prepare for it is have read everything on all the chapters from the different books on these ecosystems, and have watched all the videos and have your notes in order so that you don't have to scramble around trying to figure that out as you're trying to take the quiz. So I'll give you more information on that as it gets a little bit closer. Also, I'm going to assign your second paper, your final paper for this semester. For some of you, maybe your final paper as a college undergraduate this week. And it will have to do with restoration ecology, so restoration of an ecosystem. And it'll be a review paper, which means that you'll be reviewing some of the literature that's been published on this topic. I'll give you information on that this week too. So it's a big week. But let's talk wetlands first. So here is a map of wetlands of the world. Put together by a research group that mostly used remote sensing. So they were using satellite imagery to look at standing water and soil types and vegetation types to try to piece this together. So the red areas are wetlands. And of course, it doesn't catch everything. So some of the small wetlands don't show up on here, but the big expanses of wetlands do. So let's talk about some categories of wetlands first. We break it down into basically 5 types. 2 of them are in coastal areas, so that would be marine systems, which are in, of course, saltwater, and that includes things like salt marshes and mangrove swamps. Some of you did your ecosystem model on mangrove swamp ecosystems. And then estuarine systems, you're familiar with the term estuary. This is where freshwater meets saltwater, so we call that brackish water. And so it's usually less salty than open ocean water and more salty than freshwater. And then we have some inland wetlands. We've already talked a little bit about riverine systems. We called these riparian corridors. So these are river floodplains. And they might be dry for much of the year, but occasionally when the river floods, these areas are underwater, inundated with water, and so they are wet enough to be classified as wetlands. Lacustrine wetlands are associated with lakes, same sort of thing. They're on the fringe of a lake, and occasionally when lake waters get high, they flood, and so they are wetlands along the fringe of a lake. And then probably a word you haven't seen before, most of you, is called palustrine. Palustrine wetlands are isolated, usually small, isolated wetlands that are not associated with a greater body of water like a river or a lake or a bay. Most of the wetlands we have around central Ohio are palustrine wetlands, except we have a lot of riverine wetlands too. So these would be little shallow, sometimes ephemeral vernal pools that are only wet for a few weeks in the spring. Or if you go out west a little bit, the prairie pothole country, those are isolated little ponds. And some of these are classified as peatlands that I'll show you in a second. So marine, estuarine, riverine, lacustrine, and palustrine. Those are 5 good vocabulary words for you to know. This just shows where in the landscape you would find these. So riverine is along rivers. And there's a palustrine system here that's isolated. Another palustrine system, riverine. Here's a lacustrine system. Here's an estuarine system, and then here we are out in a marine system. Now I just have some pictures to show you. So here are some palustrine. I took some of these pictures from the internet Actually, I took some of them with a camera too. But yeah, here's some various types of palustrin marshes. Here's a peatland. Unfortunately, we won't get enough time to talk in this class about peatlands, but they're really kind of interesting. Well, all wetlands are interesting. These are some of the most interesting. These are palustrin wetlands where the hydrology is such that the vegetation has grown and then died and been submerged in water, sometimes for many thousands of years. So this peat, which is partially decayed plant matter, has built up to sometimes 10 to 20 meters. So you could dig down in this area. First of all, you'd hit water pretty quickly, but there would be very thick organic material down for many meters. And so these are interesting parts of the world, mostly in colder latitudes or in higher altitudes, like in alpine areas. Not always, but mostly. So you can see back to this map, lots of the wetlands in kind of northern Canada, Alaska, and northern Russia, Siberia. These are peatlands, and so vast acres of the world are actually peatland wetlands. Here's just an aerial photo of some peatlands. Here's a lacustrine wetland, again alongside a lake. A lot of times these have slightly deeper water habitats, although one thing for you to understand is that wetlands in general are shallow water habitats. That doesn't mean that wouldn't be over your head in some areas, it might be, but these are not systems that get as deep as a lake or even a large river. Usually sunlight can penetrate all the way to the bottom. Usually these are on the order of a few centimeters water to maybe a couple of meters of water. And for much of the year, they might actually be dry. Wetlands do not have to be wet all year round to be classified as wetlands. Here's a riverine swamp. So this is an area that would be dry for much of the year. It happens to be flooded right now. You can see how the trees are adapted to this. They have these big buttress trunks or buttress roots to give them stability in these shifting sedimentary type soils. Here's an estuary. So you can see some of the river channels. Looks like a river delta leading out to the sea here. And these are great areas for birders because there's really incredible bird diversity here. Here's the edge of a mangrove swamp. Again, some of you did this for your model. Mangroves are one of the few trees in the world that can live with their roots in standing water and in standing salt water on top of that. This is a really stressful place to live for plants, and mangroves have mastered this through evolution. And there are a few species of mangrove, actually many species of mangrove trees all around the world, but only a few that live in, say, southeastern United States. And they dominate these areas because almost no other plants can live there. Unfortunately, these are also areas where humans like to live and build hotels and resorts and things like that. So a lot of mangrove habitat has been converted into human dwellings. Here's a salt marsh, so right on the edge of the sea. This is a tidal area. Again, a pretty stressful place for plants to live. So there are only a few species of plants that can live. Actually, salt marshes are analogous to mangrove swamps. If you are a little closer to the equator, sort of equatorial, sub-equatorial, you're in mangrove country. If you go a little farther north or south, you're in salt marsh country. So if you're, let's say, on the coast of Delaware Bay or Chesapeake Bay, you're not going to find mangrove trees there. It's too far north, but you're going to find salt marshes as long as humans haven't converted it into some other use. So these are different sort of ecosystems than we've encountered before. That's why we do a separate section on them. And a couple things to know about wetlands to begin with. Again, we'll look at this in cross-section like we do most of our ecosystems. There are some deep water areas. So here it says water depth 3 to 7 feet, so a couple meters maybe. It gives you some typical plants here for our part of the world, but you don't have to really memorize any plant names here. You do get into some shallower water areas that you might call a deep marsh or a shallow marsh. And then you get into some areas, like I said, that are not flooded perhaps for much of the year. Here's a wet meadow, and you can see 0 to 6 inches of water. So you might get your feet wet this time of year if you were walking in a wet meadow. But if you went back to the wet meadow in August or September, you wouldn't know it was a wetland at all unless you knew what kind of clues to look for, because it would be dry. Unfortunately, this means we've lost a lot of our wetlands around the world to things like agriculture and construction and development because people go out to look at them in August or October and they say, hey, this would be a great place to build our parking lot because it's dry. They build the parking lot, they build the house, and then they find out, oh, it gets very wet every spring. And then we've lost that habitat and they've built in an area that probably wasn't great to build in anyway. This is called a shrub scrub wetland. So it's shrubby, but mostly dry, might only flood for a few weeks out of the year. And then here's a forested wetland. Same, it's dominated by trees, but it only floods maybe for a few weeks out of the year. And now we're into upland, so this is not wetland habitat here at the end. You notice in this list it uses this term hydric soils. Hydric soils are here. Actually, all of these have hydric soils except the upland has non-hydric soils. So hydric soils are wetland soils, and they have some particular characteristics that they've gotten because they are flooded and then not flooded, and flooded and then not flooded. And so they have some color differences, they have some nutrient differences that non-hydric soils don't have. Okay, so that gives you an idea of some of the different sorts of wetland habitats we have. A couple things to know about wetlands. One is the water budget. Where does the water come from and where does it go? So there are basically 3/4 ways water can get into a wetland. It can get in by precipitation. It can get in by surface inflow, and by that we mean runoff from upland, or a river that might empty into the wetland, or perhaps a lake or bay that might flood it. So that you could add tides in there. That's why I said 3/4. So tides could actually bring water into a wetland also. We also have potential groundwater inflow. So water beneath the surface can come into a wetland. And that's called groundwater discharge. So groundwater exists in the soil, in the spaces between soil and rock particles beneath our feet. Depending on where you are, you might have to dig down really far to find water, or it might be really close to the surface. In some areas, it's so close to the surface that when there's a depression in the landscape like this, the groundwater actually makes it to the surface. And we think of that as the aquifer in the ground is actually discharging water. So we call that groundwater a discharge wetland. The water is actually discharging from the ground. The opposite can happen too. Over on our second half of our accounting here, water can leave a wetland by going into the groundwater. We call that a recharge wetland because it's recharging the groundwater. It can flow out, surface outflow. Maybe there's a stream or a ditch or a channel. And it can evaporate or transpire through the trees. We call that evapotranspiration, or ET. Okay, so basically those are the ways water can get into and out of a wetland. And lots of wetland ecologists do what's called water budget analyses, which means trying to account for all of the water that comes in and when it goes out, where it goes out, and trying to keep a really tight budget on the wetlands water in order to understand its ecology. Because really, how the water comes in and where it comes from and what sort of nutrients it brings with it, that dictates a lot about the ecology of the system. So here's a picture of this. Same thing, but there's surface water inflow and there's groundwater inflow, trying to show you here. See if I can draw that. There we go. And then there's precipitation, and there's ET, and there's surface water out, and there's groundwater out. So yeah, this wetland is a result of all of those things. Some of these are easier to measure than others. Obviously, precipitation, pretty easy to measure if you have a rain gauge. Surface water in and out can be fairly easy to measure if you can measure flow through a stream or a ditch. A little tougher to measure if you're talking about surface runoff. Evapotranspiration, there are various ways to measure that. There are some fancy little ET meters now you can put out in the field, and it can estimate for you how much water is evaporating. Groundwater is the tough one to measure because you can't see it. You can't easily, there's no channel, right? There's no pipe down there. It's just soil pore spaces. So there are people called hydrogeologists that are good at finding ways to estimate groundwater flow. Someday maybe you'll take a hydrogeo class. Okay, so all of this is driving toward what's called the wetland hydro period. So this is sort of like the EKG for a wetland. If you could only know one thing about a wetland, you would want to know its hydroperiod. This is how the water level changes over time. So here's water level on this axis, and then on the x-axis we have the months of the year. And so we get this little curve or jagged line. And so it might, be dry for much of the year. This is the ground surface right here. It might be dry for much of the year and then flood in the spring and then be dry again. So the green line here is a riparian wetland. So that is a river flooding, and it only floods, it looks like, in April and May, a little bit into June. And then it's dry for much of the year. Some other wetlands might have very different hydroperiods, and this signature kind of tells you a lot about the ecology. So when is it wet? How wet does it get? How deep does it get? How often does it flood and then dry out? That dictates what plants can live there, what the soil conditions are, what animals can live there. So it's pretty important to know the hydroperiod. Hydroperiod is very easy to measure. All you need is a yardstick or a meter stick and plunk it in the water and maybe anchor it somehow to a concrete block or something like that, and then come out and look at it every day or every week. Or you can, if you're lazy like me, you can get an electronic meter that measures the pressure of water above it, and so you can just plunk it out in the water and then come out every month or 6 months or a year and download the data, and you get a nice little hydroperiod graph so you can see how the water levels change over time. Okay, the second most important thing to know about a wetland that's really related to the hydroperiod is this. This is zooming in on the soil. So the soil of a wetland is really important. Kind of like, actually, when we talked about drylands, for that one day we talked about drylands, and we talked about that biological soil crust, which is at the very surface of a dryland, and that little centimeter or so of soil is really important to how that ecosystem works. Similar here, although we don't really have biological soil crust. What we have is, here's the floodwater of the wetland, and here's the atmosphere, and there's oxygen up here, and some of that oxygen becomes dissolved in the water here, and some of it even diffuses down into this very, very top few millimeters of soil, and that's called the oxidized or aerobic soil layer. So there's oxygen present in that layer. If you go a little deeper than that, when the water is flooding the wetland, you run out of oxygen very quickly. Now you're down into the muck of the wetland, or peat if you're in a peatland, and it's flooded, and there's a lot of organic matter, a lot of detritus, a lot of dead raccoons, right, and things like that. And they're decomposing, and so bacteria are using up the oxygen that might have been present there, and so it's anaerobic. No oxygen. Sometimes we call that the reduced soil layer. So this zone of oxygen present and oxygen absent is really important, because this zone transfer back and forth means a lot of reduction and oxidation reactions happen in that zone, because some chemical reactions need oxygen present and some need oxygen absent. And this is a zone where just in a few millimeters you have both of those present. So that's kind of important. Okay, for all of these reasons, the flooding, the hydroperiod, the water sources, the oxygen present, oxygen absent thing, makes wetlands really good at transforming chemicals. So they transform nutrients. That just means they change them. And sometimes, for this reason, wetlands are called kidneys of the landscape. So what do your kidneys do in your body? Well, your blood flows through them, and any impurities, like, let's say, I don't know, ethanol, maybe that's in your blood for some reason, for some odd reason you ingested ethanol. Your kidney's job is to purify that, right? To remove some of those toxins, or convert them into something that's less toxic. Okay, so that your blood flowing out of your kidneys is a little cleaner than blood flowing in. That's the job, at least one job of your kidneys, right? And then to export that waste, of course. Wetlands operate in a similar, sort of analogous way, in that water that flows in might have a lot of nutrients, it might have even some toxins, it might have some sediment, and that gets into the wetland, and it goes through some cycling. And it might just be a matter of sediment settling out in the wetland and becoming part of the soil, or it might be a matter of things being taken up by plants and stored in biomass. Or it might be a matter of chemical transformations happening so that whatever form of, let's say, nitrogen that flowed in is different than the form of nitrogen that flows out. So in this respect, wetlands are really good at transforming nutrients, and they perform some really important ecosystem services for humans, or have for a long time until we destroyed them and drained them and filled them in. We're missing some of those ecosystem services now. Okay, we're going to take a quick look at the carbon cycle here just to begin with, and then we'll look at nitrogen and phosphorus next time. So here's a little sketch of a wetland. Here's a wetland plant like a cattail. And so we have this inflow water, right? It shows a pipe here, but we're just imagining water gets into a wetland, one of the ways that we talked about. And there's carbon in the wetland too. Where does the carbon come from? Well, these plants are doing photosynthesis, so they're fixing carbon into biomass, part of this plant, right? You notice here it says aerobic soil layer and anaerobic soil layer, just like we just talked about. Okay. So as that plant lives and dies, or the bugs and animals around it live and die, they eventually become part of the detritus. And here's POC and DOC, so particulate organic carbon, dissolved organic carbon. If they're in this aerobic zone where oxygen's present, respiration can happen. Bacteria break those things down and they turn into carbon dioxide. And that CO2 can just leave the wetland, just like it entered over here. So that's one cycle that can happen. Sometimes this organic carbon gets buried a little bit deeper down into the aerobic part of the wetland. I'm sorry, anaerobic soil layer of the wetland. Here's the dissolved organic carbon. And then some different processes happen because oxygen is absent. One thing that can happen is called lactic acid fermentation or ethanol fermentation. There are some specialized bacteria in wetlands that exist where there is no oxygen, and they can actually consume that dissolved organic carbon and turn it into methane gas, CH4. So here is this process called methanogenesis. So wetlands, if they are flooded long enough, can actually give off methane. So these two, you'll notice, these two gases, CO2 and methane, are greenhouse gases. So one of the big debates that's going on, and a lot of people are measuring this, is are wetlands better at taking up carbon and storing it, or are they better at releasing carbon in the form of greenhouse gases like CO2 and CH4? And the answer is, like a lot of things, it sort of depends, it seems. Peatlands, those areas I showed you in colder parts of the world, are usually really good at storing carbon. They take up carbon and it turns into peat, and the peat doesn't decompose very quickly because it's cold, and usually it's acidic in those wetlands also, and so it stays there for a long, long time, centuries or even thousands of years. Peatlands are areas, you know, where they find a mammoth or a mastodon or a human that was hunting them, and you know, fell into or was pushed into the peatland and then got buried in the peat and really didn't decompose. And we find that person 8,000 years later, and you know, we can look at, you know, what was in his belly or what sort of clothes he was wearing and things like that. So peatlands are really good at storing carbon. Probably one of the best ecosystems in the world at storing carbon. Other wetlands give off lots of CO2 and CH4 because the carbon that they take in through photosynthesis quickly gets cycled and transformed and given off as one of these gases. So it might depend what sort of wetland you're talking about to know, is it better at sequestering carbon or better at releasing carbon? Okay, so that's a quick look at the carbon cycle of a wetland. And next time, like I said, we will look at nitrogen and phosphorus, and we'll move on from there. Make sure you're reading the chapters on wetlands in the Protected Land book and the Freshwater Ecosystems book. And probably today or tomorrow, I'm going to be posting a review sheet for your quiz and also instructions for your second paper. So you can look for that on Notebowl. Have a good day.